Intermolecular forces are the forces between the two molecules. For example, two molecules of water here, so what is inside them or what type of forces is called intermolecular forces. Intermolecular forces can be polar or nonpolar. Polar intermolecular forces can be hydrogen bond or dipole dipole. Nonpolar is the London dispersion. Okay, hydrogen bond when hydrogen is bonded with F is the strongest, or with oxygen, or hydrogen with nitrogen. Dipole dipole when the molecule makes like two different sides, two different charges, positive and negative, like a magnet. Magnet has two poles, so this is the same. London dispersion, it depends on the dispersion of the electrons. Since all atoms has electrons, so London dispersion located in all molecules. Now let's try some examples. The first one here is water. Oxygen and hydrogen, so it has a hydrogen bond. Since there is different charges, look at the oxygen, it has extra electrons. I always look at the middle atom. If it has extra electrons, so this means it has a negative side. The other parts with a positive side, so it has a dipole dipole like a magnet. And it has London forces since it has atoms. London is located in all molecules. Okay, this example, does it have a hydrogen bond? Yes, and this is the hydrogen bond, O with H. So it has a hydrogen bond. So it is polar. Okay, does it have a dipole dipole? Since it has a hydrogen bond here on this side, and there is no other hydrogen bond on the other side, so they do not cancel out each other, then yes, it has a dipole dipole. And of course, a London dispersion force. HF also has a hydrogen bond. Okay, does it have a dipole dipole HF? Let's check. Fluorine has a negative charge because it has extra electrons when you do the Lewis structure. Hydrogen on the other side, it has a positive charge. Negative and positive, it's like a magnet. So it has a dipole dipole. Yes. Okay. This one. SO2. Since sulfur has extra electrons, so it has a negative charge on this side, and the other side will be positive. Do not tell me that oxygen has a negative charge. Why I wrote it as a positive? Because sulfur has an extra electron. So the extra electrons make it negative. The other side will be partially positive or positive if we compare it with the sulfur. So positive and negative like a magnet. This means it is dipole dipole. Okay. NH3. Let's do this one. Nitrogen in the middle. Nitrogen is in group number 5, so 5 electrons surrounding it with the 3 hydrogens in H3. Each hydrogen has 1 electron. Okay, after bonding, bond, bond, bond. So there are extra electrons. So negative on this side, positive on the other side. This means it is dipole dipole. Okay, it's dipole dipole. Does it have a hydrogen? N with H. Yes, it has a hydrogen also. This one. COF2. Carbon in the middle, two oxygen, no, one oxygen and two F. Since carbon must have 4 bonds surrounding it, and we cannot do the extra bond with F because F can make only one bond, it has 7 electrons. So it will be with oxygen here. Okay. Oxygen has a negative side and fluorine has a negative side, but fluorine is more negative because it's more electronegative, so it has different charges. F and O, they are different from each other. So it's like positive and negative. It's dipole dipole, and it doesn't have a hydrogen bond. Okay, take another example. Check this one. This is important. CO3 negative 2. So we call this structure a resonance structure. If it has one double bond and it can be flipped inside or between the other oxygens. So it has a shape of a trigonal planar since all of the atoms are oxygen surrounding the carbon and they are the same as each other, so they cancel out each other. So this means no different in the charges. So it doesn't have dipole dipole, it only has London. This one, the same. C C double bond H and H. Okay, hydrogen has a positive charge and the other side the same, it's hydrogen, the positive charge, so they cancel out each other. So this one is also has London forces only. Same goes for this one. Each hydrogen has another hydrogen on the opposite side, so they cancel out each other, and this cancel this, so it is only London. If they cancel out each other, this means there is no dipole dipole, no different in the charges. Same goes for heat. Two hydrogens cancel out two hydrogens, and H2 the same. There is no different in the charges, so it is only London. So this is the main idea. If you have any question, send me.